Before we go to the problem itself, do not forget I will be posting the video here. It's going to be either up or down to vote for one of the two big projects that I'm building. Your vote is going to decide which project you're going to see. So it's going to be important for the channel. Go and vote. Okay, and this once again shows you that it's very important for you to not only think the traditional way from left to right, but rather take something from the end and try to go to the beginning, see if you can actually think of something else. Welcome everyone. Today we're going to be talking about merge sort array. This is problem 88, and this problem was given by Microsoft in a coding interview. Now, this problem is going to be a bit longer and is going to have a bit more parameters. Don't get afraid, don't get discouraged. Let's read the problem and see what kind of a solution can we actually figure out. You are given two integer array, that's nums1 and nums2, sorted in non-decreasing order. It meaning it's go from 1 to, higher numbers. And two integers, this is part of the parameters over here that you can actually see them, so that's going to be m and n. Representing the number of elements in nums1 and nums2 respectively. Nums1 and 2 into single array sorted in non-decreasing order. So we need to merge them. The final sorted array should not be returned by the function, but instead the stored inside the array nums1. That's going to be a bit difficult here. To accommodate this, num1 has, of course, the length of both of the arrays, so nums1 and nums2. I'm going to explain this by drawing because it's going to look a bit simpler. And where the first m elements denotes the elements that should be merged and the last n ones are set to 0 and should be ignored. Nums2 has a length of n. All right. Now, this is the problem. The problem description. The description is actually, when I say it so quickly, probably you do not understand the idea, but always just start and draw them out. Just start, write it down, see if you can actually figure something out. Now, I'm going to go straight to the examples and I'm going to write down here, and I cannot see because of the microphone. Probably need to get a bit of a better setup, but I'm going to go with num1, and num1 is going to go 1, 2, 3. It's going to have these numbers, and as we said, it needs to hold respectively the numbers of the number length of the other array. So of course 0, 0, 0. I'm going to explain this why it's so. Let's go with num2 and I'm going to write it down. It's going to be 2, 5, and 6. The two parameters that we're actually getting are m and n. So m is going to be 3 and n is also going to be 3. Now, what are these two parameters showing you is that m3 is showing you how much elements do I have in nums1 respectively, and 2 is going to be n is going to be showing you how many numbers do you have in num2. The whole idea is that we should be returning an array, and you can see it down here, and you can see it actually pretty well. 1, 2, 2, 3, 5, 6. Now, if I'm taking this array, you're going to see that num1 is accommodating these numbers, right? So it has 6 spots, and all of these 6 spots are actually filled. So it's going to be 1, 2, 3, and then we have the 3 zeros, which are going to be bringing us to 6 spots in general. And num2 is having these 3 numbers right over here that we actually need to accommodate to num1. What we need to do is to actually put these numbers in num2 in num1 and return num1, meaning that our space complexity is required to be constant because we're not creating any other array, right? We're not filling any other array. We need to fill the number 1 that we're given. And there's one way to do that. Now I am going to draw something right over here. I do not want to delete it just yet. Now, one way to, okay, that was pretty bad. I don't know what's happening. All right. So as I said, I'm going to draw down here because I do not want to delete it yet. When I go with the first 1, 2, 3, and then I can have zeros and 2, 5, 6. Right? You can do it with the 2-pointer method, and we're actually going to do that, but we're going to start from left to right, right? This is like the most intuitive way to start. I always start to think from the beginning to the end because I think that we humans just think, I'm going to start something, I'm going to do something, and then I'm going to finish it, right? Nobody thinks about, all right, let's go on the finish line and go through the beginning. It's just not intuitive. And if you're thinking about the intuitive way, so start from the beginning and go to the end, you're going to see that if I start with 2 pointers over here, and probably if you have thought about it on your own, you're probably with the same conclusion here. you are going to check against these two values, and you're going to see if the first value is actually smaller, right? I want to go up. Now I'm going to go here, and 2 is 2, so 2 are going to be equal, these values, meaning that I don't need to necessarily do something here, so I'm just going to go up again. Now I'm going to go to 3, and now I know that this 2 here should be in the place of this 3. However, if I do that, then it becomes a problem because I need to place this 3 over here, but I don't know if this is going to be 0, meaning that the element that I'm allowed to place is at 3. It might be 4, so I need to store this 4 and just traverse the array and make it, change it over the way. That's a horrible way to think, and in order to make it better, we can actually store them in another array, which is not allowed here because, as I said, we need to be returning num1. So here comes the confusion. What do I need to do? It's like you don't really see a good way to do it. Now I'm going to write it again. I'm going to write nums1, which is going to be, as I said, 1, 2, 3, 0, 0, 0. And what was the other one? It was num2. And num2 was actually having 2, 5, 6. So how about that? I'm going to take 1, 2, 3, 0, 0, 0. And then I'm going to take 2, 5, 6. Now keep in mind, these are the same arrays over here. So this one is going to be num1, and this one is going to be num2. I'm going to go from the end. This is something that I have already been talking about in the channel. You should think about non-intuitive ways. They are going to be showing the interviewer that you have some experience with such problems. You don't need to necessarily figure out the problem on your own, but just think about different ways. If the first way doesn't happen, or doesn't work out, just don't be afraid. Let's go with the second way. If it doesn't work out, let's go with the third way. The more ways you actually can think about it, the more ways you can show to the interviewer, the bigger your value is going to be. So you're going to be more valuable. Now, I'm going to go from the finish to the start. Again, non-intuitive. How am I actually going to do it? Now, I'm going to check this number over here is going to be, keep in mind, this is very important. They are sorted in non-decreased order, meaning that this number here on the right, on the rightest spot, right, is going to be huge. It's going to be the biggest number. Obviously, it's going to be the biggest number because that is how we are sorting the number. So the number on the left is going to be the smallest and the right is going to be the biggest. So here I'm actually going to change. I'm going to check, all right, I'm going to keep 3 pointers actually. This is going to be, since I know how many numbers I have in num1, I'm going to keep a pointer to the last element. The last element of number 1 is going to show me actually, right, if I have a bigger number. So how is that possible? Well, again, on the rightest spot, I'm going to have the biggest number from the array. And the same is going to apply to num2 and to num1. Now I'm going to check these. And if I see that this number, right, is bigger than this number, it means that it should definitely be here. It should definitely be here because this is going to be the biggest number. It needs to be on the rightest spot of the array. Now I'm going to do that. I'm going to write 6 here. Then I'm going to change this and change this. So let's go with red color now. I want to go with red because it's going to be showing you where we are at. Okay, good. So now I'm actually at number 5. At number 5, here we're at number 3. We haven't changed, right? We haven't done anything. We're at number 3. And now we're checking, is 5 bigger than 3? If it is, it means that it really needs to stand on the right side of 3, not on the left, since it's bigger. It is bigger. Here is 0, so I'm completely allowed to write the number without any consequences, because if I have a number here, right, I need to take into consideration the fact that this number still needs to exist somewhere on the left or to the right, and it's going to be a bit of a problem. I have 0 here. I'm completely allowed to write my number, and I'm going to be writing my number 5. Good. Now I'm going to switch with green color. I'm going to show you. I'm going green here, and I'm going green here. Now here is interesting. What are we going to do if the number is smaller? Now, keep in mind, we have started from the end to the start. We're not going to now start from the start and go to the end. It doesn't make any sense, right? I'm going to check if 2 is bigger than 3. It's not, meaning that 3 should stand on the right side of 2, right? But if I change it here, you're going to notice that 2 is going to be standing here, right? Which is definitely not right. This is not going to be a sorted array. Oh, and by the way, what we can do is just add the numbers over here and then call sort, right? But this is going to be n log n space time complexity. And here we're set, we had something that I didn't show it to you, but we have to have a specific time complexity here. Now what I can do, obviously I'm going to control Z. I'm going to write 3 here. I'm going to write 3 here. So I'm going to write this number and I'm going to be placing it 3. And now I'm going to move this pointer here and of course this pointer over here on the spot of 3. 3 is now copied. So we have, if you think about it, can I write with green? Are you going? Yeah, okay, I think you can see it well. Now we have this array, 1, 2, 3, 3, 5, 6. We have this. So I've copied 3, I moved this pointer here to 3, and now I moved this one again. So this is point 3, this is point 2, which is going to be moving here, and this is point 1. And obviously I needed to write them in different colors, but you know, this video is going to get way too long. Now, I'm going to be moving this first pointer, which is going to be showing me the highest element in the number 1 array, because now I already have figured out what is going to happen with 3. I don't need to worry about 3 anymore. I need to worry about the second largest element, which is going to be 2. Now, 2 is not bigger than 2, it's equal, and that is why I'm allowed to take this 2 and write it down to this pointer, so the second one that I'm keeping over here, and I'm going to remove the 3, write the 2. Obviously, I'm going to be done with num2. I've merged them, and I'm going to end up with this array. 1, 2. Here we do not have 3 because we have copied 2 on this value. 2, 3, 5, 6. And let's check against this. As you can see, completely right. Sounds good. Let's code it up. Okay, now I'm going to be removing my pen here, and I will try to where is my mouse? To code it up, of course. Okay, good. So now I said that we need to be keeping some elements as pointers. What I'm going to do is I'm going to keep the first array index. So I'm going to say first array, and actually I'm going to move the tablet just so I can write it better. All right, so the first array. Now the first array item shower, item index, it doesn't really matter. This is going to be m minus 1, right? It's going to be m minus 1 because obviously we are having the m, which is showing you the nums1 length. So I'm just going to take it. What we can do, obviously, is nums1.length minus 1. Oh, no, actually, no. We cannot do that because nums1 is having zeros over here, and m is actually showing you how many numbers do we have that do not consider the fact that we have zeros in order to accommodate num2 array. And that is why I'm actually going to say m minus 1. The next one is second. So this is going to be second array item. And this is going to be obviously n minus 1 because n minus 1 is going to be showing you how many numbers do we have in nums2. This, however, can be written like that. This can be written like that because again, we're not taking into consideration num1, the fact that we have something left to accommodate num2. But again, as we're given the parameter, I'm just going to be using n minus 1. But you can check it on your own if you want. Now, we're going to be talking about the last index. The last index is going to be, last array index is going to be equal m plus n minus 1. And actually, these should be, it doesn't really matter, but let's write them like that. Now, m plus n minus 1 is going to be showing you these here, right? Because we said num1 has the potential to cover num2, because otherwise the problem is not going to be working. And I need to take this number. This index, sorry, not number. It's index. All right, so now I'm going to, how long am I actually going to work? Now I'm going to work until I have merged the two arrays, and I'm going to merge the lowest array, the lowest part of the array to the highest part of the array. We have two arrays. One is long and the other one is short, and I need to merge the short array to the long array. So I'm going to go second array item is bigger or equal than 0, right? I'm going to do that because the nums2 is actually going to be the shortest array, the shorter. All right, if first array item is bigger or equal than 0, meaning that we have a valid candidate for num1, right? I am going to check, did I write that down? Nums1 of the first array item, if this is bigger than nums2 of second array item, we are going to do nums1, and you don't write it like that, and you don't write it like that again, last array index, and then we're going to go minus minus is going to be equal to nums1 of first array item, and again minus minus. So what are we actually checking here? I'm checking if the num1 first array item, right, and this is going to be my last index actually, so this is going to be the biggest number in num1. I'm going to be checking this, again the biggest number of num2. Now if this one is bigger, I'm going to take the, if you think about the problem when I draw 1 and 2, think about 1 and 2 in green, it was like around minute 6 I think, or 7 or 8. Think about 1 and 2. I'm going to remove the last index down from the num1 array, and then I'm going to switch these numbers. This is when we had the array which ended up looking like 1, 2, 3, 3, 5, 6. So think about this one. I showed it in the drawing. Else I'm just going to do this. Nums again, last index, last array index minus minus is going to be equal to nums2 of second array item. And obviously I am going to just do that. Now, if this is not the case, what I'm going to do is I'm just going to put it in the last index, right? Put the second array item, and here we need to say minus minus, put the second array item, the second array's largest number into my last array index and move 1 down. That's pretty much it. Let's run the code and see if we're going to make it. All right, good. And here, yeah, I'm just going to submit to the server. I'm not going to use any example test cases. Let's just see if this is going to work. And boom, there we go. So this is the problem. Now, if you have any questions, leave them down below. It's a bit trickier, this problem, but I think I like it pretty much. It's very unique, it's very interesting, and once you actually get the idea, it's not that difficult when you think about it. It just makes sense. Thank you for watching, and I'll see you in the next one. Bye.